Dear all, welcome again to LR Academy for Competitive Exams. This time to the special post number 4 on the fundamentals of chemistry to high school and higher secondary students. In this class, we look at the concept of molar volume, oxidation number, and calculation of oxidation number from the underlined species. That is for the underlined species. Now we move to the first concept. What do you understand by the term molar volume? Molar volume, the definition goes by the volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is coined by the name molar volume. Molar volume is applicable to gaseous substances. Instead of using the mole concept for gaseous substances, we use the term molar volume. 1 molar volume of any gas equals 22.4 liters or 22,400 milliliters. Again, I repeat, 1 molar volume of any gas equals 22.4 liters or 22,400 milliliters. Now, let us see a problem. Calculate the molar volume occupied by 44 gram of carbon dioxide gas at STP. Again, I repeat, calculate the molar volume occupied by 44 gram of carbon dioxide gas at STP. Now we look into the problem. First, we have to calculate the molar mass of 1 mole of carbon dioxide. We have to calculate the molar mass of 1 mole of carbon dioxide. As you are aware, one mole of carbon dioxide contains, that is 1 molecule of carbon dioxide contains 1 atom of carbon and 2 atoms of oxygen. 1 atom of carbon and 2 atoms of oxygen. Hence, 1 into 12 gram plus 2 into 16 gram, which equals 44 gram. So, molar mass of 1 mole of carbon dioxide is 44. 12 represents the atomic mass of carbon and 16 represents the atomic mass of oxygen. 1 represents the number of atoms of carbon and 2 represents the number of atoms of oxygen. So overall, molar mass of 1 mole of carbon dioxide equals 44 grams. Now we have to calculate the number of mole. So what is the given mass as per the question? 44 grams. Molar mass of 1 mole is 44 grams. So 44 divided by 44 will give us the answer 1 mole. So 1 mole equals 22.4 liters, which is the molar volume occupied by 1 mole of carbon dioxide. Since it is a gaseous substance, carbon dioxide, we are quantifying the quantity of a chemical substance in molar volume, in the unit molar volume. Now moving to the second concept, what do you understand by the term oxidation number and its calculation? How do we calculate? It is defined as the imaginary charge left on the atom when all other atoms present in the compound has been removed in the usual oxidation states, that is, they are assigned accordingly to a set of rules. So, it is defined as the what? Imaginary charge left on the atom when we know the oxidation number of the remaining atoms or remaining elements present in the molecule. Yes. The oxidation state of a free element, that is in its uncombined state, is assigned the value of 0. The oxidation state of a free element, that is in its uncombined state, is assigned the value of 0. Generally, group 1 elements, that is alkali metals, group 1 elements exhibit a oxidation state of +1. Group 1 elements, that is alkali metals or alkali elements, generally exhibit a oxidation state of +1. Group 2 elements, that is alkaline earth metals, exhibit the oxidation state of +2. Again I repeat, group 2 elements exhibit a oxidation state of +2. Generally, oxygen exhibit the oxidation state of -2 in its compounds like water, carbon dioxide, etc. However, exceptions, விதிவிலக்கு, exceptions do occur in the case of peroxides, superoxides and oxyfluorides. Oxygen generally exhibit an oxidation state of -2 in its compounds. However, exceptions do occur in the case of peroxides, superoxides, and oxyfluorides. Hydrogen generally exhibit an oxidation state of +1. Hydrogen generally exhibit an oxidation state of +1. However, exception to this +1 oxidation state even occur in the case of metal hydrides such as lithium hydride, calcium hydride, sodium hydride, NaH, where it exhibits -1 oxidation state. Manganese, the symbol is Mn, exhibit variable oxidation state ranging from +2 to +7. That is +2, +3, +4, +5, +6 and +7. Manganese exhibits variable or different oxidation states. Now let us see oxidation number with a simple problem. Calculate the oxidation state of the underlined species. Manganese sulfide. Manganese sulfate. Here the compound, here the element underlined is S, sulfur. Manganese sulfate. Here the compound, here the element underlined is, or the species underlined is sulfur. Yes. MnSO4, 1 atom of manganese, therefore 1 into +2, 1 atom of sulfur, which you have to determine, hence we will put X. 4 atoms of oxygen, hence 4 into -2. So +2 plus X minus 8 equals 0. On simplification, we get X minus 6 equal to 0. That is X equal to 6. Here X refers to the underlined species sulfur. S refers to the underlined species sulfur. So sulfur exhibits an oxidation state of +6. Kindly excuse, it is not Mn, it is sulfur +6. Next, carbon dioxide. Here the underlined species or element is carbon. So 1 into X plus 2 into -2. Hence X minus 4 equals 0. X equal to +4. Here X refers to carbon. That is carbon +4. Now moving to the next problem. Potassium dichromate K2Cr2O7. K2Cr2O7. Here the underlined species or element is chromium Cr. 2 atoms of potassium, hence 2x, 2 multiplied by +1, chromium 2, hence 2x, oxygen 7, hence 7 into -2, so +2 plus 2x minus 14. On simplification, we get 2x minus 12 equal to 0, that is 2x equal to 12. X assumes the value of what? +6. Here X refers to chromium. The oxidation state of chromium is +6. I have given you 2 homework problems for you. KMNO4, in which the underlined species is manganese, Mn. KMNO4 stands for potassium permanganate. H2SO4, which stands for sulfuric acid. In this case, the underlined species is sulfur. Okay. I hope next post will be on Friday on empirical and molecular formula calculation. Thank you.